So the problem here is that we have this curve y is equal to 1 plus 6x squared. And then what we do is we rotate this curve around the y-axis out to a radius of x equals 4 to form a sort of bowl shape. And so then what we need to do here is figure out the surface area of this bowl. So generally, the formula for surface area for functions defined in terms of x and y is an extension of the arc length formula. And so it is the area is equal to the integral over the region that we're concerned with of the square root of 1 plus the derivative of the height with respect to x, that squared, and then the same for y. So dh over dy squared. And then this is over, we integrate this over x and y. So here, instead of doing it over x and y, we notice that the shape is rotationally symmetric. So we're going to do it over polar coordinates. So it's going to be over r and theta. And then in particular here, we have theta going from 0 to 2 pi, and we have r going from 0 to 4. And then in the meantime, we're also going to redefine the function in terms of r. So we've got this new function h of r, and h of r is just 1 plus 6r squared. So we do the same thing here with the derivative squared. So it's 1 plus the derivative with respect to r. So it's 12r, and then that squared. And then since it's in polar coordinates, we pick up a factor of r on the differential. And then so it's r d theta dr. And then so this integral of, we have a square root with a variable squared inside, and then the same variable outside of the square root to the first power. We do this integral through a u-substitution. So we turn whatever's inside the square root here into u, and then we just take this derivative and solve it that way because it becomes much simpler. So we define u is equal to 1 plus 144 r squared. And then du is equal to 288 r squared. So then at our bounds here, which is r equals 0 and r equals 4, so r equals 0 corresponds to u is equal to 1, and then r equals 4 corresponds to u is equal to 144 times 16. So that is 2304 plus 1. So it's 2305. So then our integral is the integral from 1 to 2305, and then integrate again from 0 to 2 pi of the square root of u d theta du. Oh, and then du, we have to divide by 288 to convert from du to dx. So times 1 over 288. I'm sorry, this shouldn't be r squared. This should just be r. So now we have this integral set up, which is just something that we can do. So it's the integral from 1 to 2305 of the square root of u times, we do this first integral, and we just get a result of 2 pi. So 2 pi times 1 over 288 is pi over 144. And then this, we still have to do the du integral. And then now we can finally evaluate this, and we get and then so we get 2/3 times pi over 144 times u to the 3/2, evaluated at 2305 and 1. And so we get our final answer of pi over 216 times 2305 to the 3/2 minus 1.